Tonight, while you sleep, something remarkable is happening across the United States. It is not dramatic. It will not make the news. No one will post about it on social media. But right now, at this very moment, thousands of systems are working in perfect coordination to make sure that when you wake up tomorrow morning, everything feels normal. The lights will turn on. The water will flow. The coffee will brew. The roads will be clear enough to drive on. The grocery store will have fresh milk on the shelf. Your phone will be charged. The gas station will have fuel. The hospital down the street will still be open. And none of this will surprise you. None of it will seem unusual. You will walk into your morning as though the world simply paused while you were unconscious and resumed the moment your alarm went off. But it did not pause, not even for a second. There is an entire hidden version of America that operates between sunset and sunrise. It is enormous. It is complex. It involves millions of people, billions of dollars worth of machinery, and systems so deeply embedded into the landscape that most of us have never once stopped to consider them. We walk over them. We drive past them. We flip switches connected to them. And we almost never ask how any of it actually works. That is what this story is about. Not the America you see during the day, but the one that works through the night to make the daytime version possible. Let us start with something so basic that it almost feels silly to mention. Electricity. You probably used some in the last 10 seconds. The screen you are looking at right now is powered by it. The room you are sitting in is likely lit by it. The air you are breathing may be heated or cooled by it. Electricity is so constant, so universally present in modern American life, that we have essentially stopped thinking of it as a service. It feels more like a natural condition, like gravity, like air. But electricity is not natural. It is manufactured. Every single watt of it is produced somewhere, transmitted across vast distances, stepped down through transformers, routed through local grids, and delivered to your outlet at exactly the right voltage and frequency. And this process does not stop at night. In fact, nighttime is when some of the most critical work in the electrical system takes place. Here is something most people never consider. The amount of electricity a country uses changes constantly. It rises in the morning when people wake up, peaks in the afternoon when factories and air conditioners are running full blast, and dips in the late evening as people go to bed. This curve is called the load profile. And managing it is one of the most complex balancing acts in all of engineering. During the day, grid operators can see demand coming. They know that at 7 in the morning, millions of coffee makers will turn on within the same 30-minute window. They know that at 5 in the afternoon, electric ovens and televisions and lights will surge across suburban neighborhoods. These patterns are predictable. They have decades of data to work with. But at night, different challenges emerge. Demand drops, which sounds like it should make things easier. It does not. Power plants cannot simply be turned off and on like a lamp. A large coal or nuclear plant takes hours, sometimes days, to ramp up or shut down safely. So grid operators have to figure out how to keep these massive generators running while also not producing more electricity than the grid can absorb. Too much supply with too little demand creates frequency imbalances. And frequency imbalances, if unchecked, can damage equipment, destabilize entire regions, and in extreme cases, trigger blackouts. So what happens in the middle of the night at a power plant? Quite a lot, actually. At a typical natural gas plant somewhere in the mid-Atlantic region, the control room never goes dark. There are always operators on duty, watching screens filled with temperature readings, pressure gauges, turbine speeds, and output levels. These are not passive observers. They are making constant micro-adjustments. A slight change in ambient temperature outside can alter the efficiency of a gas turbine. A shift in wind speed can change how much power nearby wind farms are contributing to the grid. Every variable matters, and they all change continuously. The operators communicate with regional transmission organizations, sometimes called RTOs, which coordinate electricity flow across large portions of the country. In the eastern United States, an organization called PJM Interconnection manages the grid across 13 states and the District of Columbia. Their dispatchers work around the clock, issuing instructions to power plants about when to increase or decrease output. It is a constant negotiation between supply and demand, happening in real time, every minute of every night. One of the lesser-known aspects of nighttime grid management is maintenance scheduling. Many of the most critical repairs and upgrades to the electrical grid can only happen at night, precisely because demand is lower. High-voltage transmission lines that carry power across hundreds of miles need to be inspected, repaired, and sometimes replaced. Transformers at substations need servicing. Switching equipment needs testing. And much of this work requires taking sections of the grid temporarily offline, which is far safer and less disruptive to do at 2 in the morning than at 2 in the afternoon. The crews who perform this work are among the most skilled and least visible workers in the country. Linemen, substation technicians, relay engineers. They drive out in trucks loaded with specialized equipment, often to remote locations, along transmission corridors that cut through forests, farmland, and mountain passes. They work under floodlights in freezing temperatures or sweltering humidity, depending on the season. And they do it with the knowledge that a single mistake on a live high-voltage system can be fatal. There is a quiet pride in this work that rarely gets acknowledged publicly. These are people who understand that the American standard of living depends, quite literally, on their ability to keep the grid intact. And they do it while the rest of the country sleeps. But electricity is only one layer of the overnight infrastructure. Beneath every city in America, there is another system working just as hard, and arguably even less appreciated. Water. Think about what happens when you turn on a faucet in the morning. Water comes out. It is clean. It is safe to drink. It is the right temperature. And it arrives with enough pressure to fill a glass in a few seconds. This seems so simple that it barely registers as an event. But behind that simple act is an extraordinarily complex chain of processes that has been running all night long. Most American cities rely on a combination of surface water sources like rivers, lakes, and reservoirs, along with underground aquifers. The water from these sources is not ready to drink. It contains sediment, microorganisms, dissolved minerals, and sometimes industrial or agricultural contaminants. Before it reaches your tap, it has to go through a treatment process that typically involves coagulation, sedimentation, filtration, and disinfection. Each of these steps requires careful monitoring and adjustment, and the treatment plants that perform them operate 24 hours a day. At night, treatment plant operators monitor chemical feed rates, check filter performance, test water samples, and make adjustments based on changes in source water quality. If it rained heavily earlier in the day, the incoming water might carry higher levels of turbidity, meaning more suspended particles. The operators have to respond by increasing coagulant doses or adjusting filtration rates. If temperatures dropped, they might need to modify disinfection contact times because cold water requires longer exposure to chlorine or ultraviolet light to achieve the same level of pathogen reduction. Once the water is treated, it enters the distribution system. This is where things get interesting from an engineering standpoint. A city water system is not simply a network of pipes. It is a pressurized system that has to maintain consistent pressure across thousands of connection points at varying elevations, across miles and miles of pipe of different ages, materials, and diameters. Maintaining this pressure requires pumps, and those pumps run all night. Many cities use elevated storage tanks, the classic water towers that dot the American landscape, to help maintain pressure through gravity. During periods of low demand, typically late at night, pumps push water up into these tanks. Then, during peak demand periods, the stored water flows back down, supplementing the pumps and smoothing out pressure fluctuations. It is a simple concept that has been in use for over a century, but it requires careful calibration. If a pump fails overnight, or if a main breaks somewhere in the system, operators have to respond quickly to prevent pressure drops that could affect fire suppression capability, hospital operations, or simply leave thousands of homes without water in the morning. And then there is the part of the water system that nobody wants to think about, but everyone depends on: wastewater. Every drop of water that goes down a drain, a toilet, a sink, a shower, or an industrial discharge point has to go somewhere. It flows through a separate network of pipes, often running beneath the same streets as the clean water mains, but in a completely different system, toward wastewater treatment plants. These plants are engineering marvels that most people have never visited and would probably prefer not to. A modern wastewater treatment plant uses a combination of physical, biological, and chemical processes to clean used water before releasing it back into rivers or the ocean. The biological treatment stage is particularly fascinating. It relies on cultivating specific communities of microorganisms, essentially bacteria and other tiny creatures that eat the organic matter in sewage. Maintaining these biological colonies requires precise control of oxygen levels, temperature, and flow rates. And it has to happen continuously, including through every hour of the night. Wastewater operators on the night shift walk through enormous aeration basins where the water churns and bubbles, checking dissolved oxygen levels and observing the color and consistency of the mixed liquor, which is the technical term for the combination of wastewater and active biological material. They monitor clarifiers, where treated water separates from settled solids. They check chemical feed systems that add compounds for phosphorus removal or pH adjustment. And they keep detailed logs of everything, because regulatory agencies require proof that effluent quality meets environmental standards at all times, not just during business hours. It is one of those systems that becomes visible only when it fails. A wastewater treatment plant malfunction can result in raw or partially treated sewage entering waterways, which is both an environmental disaster and a public health emergency. The people who prevent this from happening at 3 in the morning are rarely thanked or even noticed. But their work is as essential as anything that happens in any office building during the day. Now, beneath and beside the water and sewer systems, there is yet another hidden network that most people never see. Natural gas pipelines. In many parts of America, homes and businesses are heated by natural gas, and the system that delivers it operates around the clock. Gas flows through a vast network of transmission and distribution pipelines, regulated by compressor stations that maintain pressure over long distances. At night, control centers monitor flow rates, pressure levels, and leak detection systems. If a pressure anomaly is detected, technicians are dispatched immediately, regardless of the hour. The scale of this network is almost hard to comprehend. The United States has more than 2.5 million miles of natural gas pipeline. That is enough to circle the Earth more than 100 times. And the system is monitored constantly through a combination of electronic sensors, manual inspections, and aerial surveys. Much of the preventive maintenance, including valve testing, cathodic protection checks to prevent pipe corrosion, and pressure regulation adjustments happens during off-peak hours, meaning late at night or in the early hours before dawn. There is something almost philosophical about standing in a quiet neighborhood at 2 in the morning and knowing that beneath your feet, gas is flowing, water is moving, sewage is being carried away, and electrical cables are humming with current. The ground beneath a sleeping city is not still. It is alive with engineered systems that have been layered on top of each other over more than a century of continuous development. Some of those pipes were laid during the presidency of Theodore Roosevelt. Some of those electrical conduits date back to the era of Thomas Edison. And yet they are expected to function flawlessly tonight, tomorrow night, and every night after that. This is the fundamental paradox of American infrastructure. It is old enough to have deep historical roots, yet it is expected to perform with modern precision. And the people who keep it working overnight are the ones who bridge that gap, compensating for aging materials and outdated designs with skill, experience, and constant vigilance. But utilities are only part of the story. While the pipes flow and the generators hum, something else is happening across the American landscape. Things are moving. Right now, at this moment, there are freight trains crossing the Great Plains. Long trains. Some of them stretch for 2 miles or more, carrying grain, coal, chemicals, lumber, automobiles, and intermodal containers filled with consumer goods from 6 countries. These trains move primarily at night, and there is a very practical reason for that. During the day, passenger rail services occupy many of the same tracks, particularly in the Northeast Corridor and in commuter-heavy metropolitan areas. Freight railroads, which own most of the track in the United States, negotiate schedules with passenger operators, and the result is that a large proportion of freight movement happens between late evening and early morning. The tracks that carried commuters to their offices during the day are carrying refrigerated containers of produce from California to Chicago while those same commuters are asleep. The logistics of nighttime freight rail are managed from dispatch centers that look remarkably like something out of a science fiction film. Enormous screens display track maps covering entire regions. Dispatchers communicate with locomotive engineers by radio, issuing movement authorities, coordinating meets and passes on single-track sections, and rerouting trains around maintenance zones or equipment failures. Every decision has downstream consequences. Delaying one train by 20 minutes at a siding in Kansas can ripple through the network and affect delivery schedules in Atlanta 2 days later. The trains themselves are operated by two-person crews, an engineer and a conductor, who often work through the night in the cab of a locomotive weighing over 200 tons. The engineer watches the track ahead, monitors speed restrictions, and responds to signal indications. The conductor manages communications, paperwork, and is responsible for the train as a whole. They work in shifts that can stretch to 12 hours, crossing state lines and time zones while most of the country is unconscious. There is a particular quality to riding in a locomotive at night that railroaders sometimes describe, but outsiders rarely understand. The headlight cuts a narrow beam through absolute darkness. The horn sounds at every crossing, echoing across empty fields. The rhythm of the rail joints creates a steady pulse beneath the cab floor. And the towns you pass through are nothing but clusters of dim lights slipping by in the periphery. It is isolating, meditative, and strangely beautiful. And it is happening right now, on thousands of miles of track across the country. But trains are only one part of the overnight freight network. The highways are busy too. If you have ever driven on an interstate at 3 in the morning, you have probably noticed that while passenger cars are scarce, trucks are everywhere. This is not a coincidence. The trucking industry moves approximately 70% of all freight in the United States by value, and a significant portion of that movement happens overnight. There are several reasons for this. Urban areas often restrict truck traffic during peak hours to reduce congestion. Delivery windows at warehouses and distribution centers are frequently scheduled for early morning arrival. And many trucking companies incentivize night driving because the roads are less crowded, which means better fuel efficiency and faster transit times. The long-haul trucker driving through the night is one of the most iconic and least understood figures in the American economy. These drivers spend days or even weeks on the road, sleeping in the small berths behind their cab seats, eating at truck stops, and navigating a complex web of federal regulations that limit their driving hours and mandate rest periods. The hours of service rules, administered by the Federal Motor Carrier Safety Administration, dictate exactly how long a driver can be behind the wheel before being required to rest. These rules exist because fatigue is one of the leading causes of truck accidents. And yet the economic pressure to deliver goods on time means that drivers often push right up to the legal limits. At truck stops along major corridors like Interstate 40, Interstate 80, and Interstate 95, the parking lots fill up after dark with rows of idling tractor trailers. The drivers inside are sleeping, or trying to. Some run auxiliary power units to keep their climate control systems working, without idling the main engine. Others simply leave the big diesel running all night, a practice that wastes fuel and generates noise, but provides reliable heating or cooling in extreme weather. These truck stops are small economies unto themselves. They offer showers, laundry facilities, restaurants, convenience stores, and sometimes even barbershops and chapels. They exist because the trucking industry never stops, and the people who drive within it need places to live, however temporarily, while they are on the road. It is a world that most Americans interact with only when they stop for gas on a road trip. But it is always there, always functioning, always keeping the supply chain intact. And it is the supply chain, ultimately, that connects all of these nighttime systems together. The electricity keeps the warehouses lit and the refrigeration units running. The water keeps the processing plants operational. The trains bring the raw materials. The trucks carry the finished goods. And by morning, when you walk into a store and pick up a bag of coffee or a gallon of milk or a box of cereal, you are holding the end product of a chain that was in motion all night long, crossing state lines, passing through inspection points, being scanned and tracked and loaded and unloaded by people whose names you will never know. This is not a system that was designed all at once. It evolved. It grew piece by piece over more than a century. Each new technology and each new regulation, adding another layer. And now it operates with a complexity that no single person fully understands. There are experts in grid management who know nothing about wastewater treatment. There are trucking logistics specialists who have never set foot in a rail dispatch center. There are water engineers who could not explain how a gas turbine works. And yet all of their systems depend on each other, interlocking like the gears of an enormous machine that runs without a master switch. The question is not whether this machine works. It does. Every morning is proof of that. The question is how. And more importantly, what happens when part of it does not? The idea that everything simply works is one of the most comforting illusions of modern life. You flip a switch and the light comes on. You turn a handle and water pours out. You drive to the store and the shelves are full. It all feels automatic, almost inevitable. But inevitability is not how engineers describe these systems. They use words like redundancy, tolerance, and fail-safe. And those words exist precisely because failure is not a theoretical possibility. It is a certainty. The only question is, when? To understand how America keeps running through the night, you also have to understand what happens when it stumbles. Because the systems that operate in the darkness are not just producing and delivering. They are also constantly preventing disaster. Consider the electrical grid again. On the evening of August 14, 2003, a software bug in an alarm system at a power company in Ohio went unnoticed. A series of high-voltage transmission lines sagged into overgrown trees and tripped offline, one after another, in a cascading sequence that spread across 8 states and parts of Canada within a matter of minutes. 55 million people lost power. Traffic lights went dark. Water treatment plants shut down. Subway systems stopped. Elevators trapped passengers between floors. Hospitals switched to emergency generators and hoped the fuel would last. The blackout of 2003 did not begin with a dramatic event. It began with a quiet failure that nobody caught in time. And that is the nature of most infrastructure failures. They do not announce themselves. They creep in through overlooked maintenance, deferred repairs, aging components, and the slow erosion of margins that were once considered safe. The aftermath of that blackout reshaped how the American grid operates at night. New reliability standards were established. Vegetation management programs were expanded to keep trees away from transmission lines. Real-time monitoring systems were upgraded, and the role of the nighttime grid operator became even more critical because the blackout had exposed a simple truth. The hours when demand is lowest are also the hours when vigilance is most likely to slip. Fewer people are watching. Fewer managers are on call. And the temptation to assume that a quiet night means a safe night can be dangerously seductive. Today, grid control centers operate with layers of redundancy that did not exist 20 years ago. Operators use synchrophaser technology, which measures the precise electrical phase angle at multiple points across the grid 60 times per second, to detect instabilities that older monitoring systems would have missed entirely. They run contingency analyses continuously, modeling what would happen if any single component failed, and preparing response plans before anything goes wrong. It is a system built on the assumption that something will go wrong. The goal is not to prevent all failures, but to contain them before they spread. This philosophy extends far beyond the electrical grid. It runs through virtually every critical system that operates overnight in America. Take natural gas distribution. In the early morning hours of February 6, 2018, a gas main break in a Dallas suburb sent a column of flame into the sky that was visible for miles. The rupture was caused by a construction crew that had inadvertently struck a high-pressure pipeline while excavating for a new development. The gas company had maps showing the pipeline location, but the maps were based on surveys conducted decades earlier, and the actual position of the pipe had shifted slightly due to ground movement over time. Incidents like this happen more often than most people realize. The United States experiences hundreds of significant pipeline incidents each year, ranging from small leaks detected by pressure monitoring systems to catastrophic ruptures that require neighborhood evacuations. And the prevention and response systems for these incidents operate around the clock. Gas utilities maintain 24-hour emergency dispatch centers where calls from the public, from automated leak detection sensors, and from field crews are received and prioritized. If you have ever called your gas company to report the smell of gas, the person who answered was likely sitting in one of these centers, following a protocol that classifies the report by severity and dispatches a technician within a specified response time. For a confirmed gas leak inside a building, that response time is typically measured in minutes, not hours. Even at 3 in the morning, the technicians who respond carry portable gas detection equipment and are trained to assess whether a leak poses an immediate explosion risk. They can isolate sections of the distribution system by closing valves, ventilate enclosed spaces, and coordinate with fire departments if necessary. It is dangerous work made more difficult by darkness, cold weather, and the fact that the people they are trying to protect are often asleep and unaware of the danger. But gas leaks are only one category of overnight emergency. Water main breaks are another, and they happen with remarkable frequency across the country. The American Society of Civil Engineers has estimated that there are approximately 240,000 water main breaks per year in the United States. That works out to roughly 650 per day. Many of these occur at night, partly because temperature drops cause pipes to contract and crack, and partly because reduced demand during nighttime hours can cause pressure fluctuations that stress weakened joints and fittings. When a water main breaks, the effects can be immediate and dramatic. Streets flood, sinkholes open, basements fill with water, and downstream, customers lose pressure or service entirely. Repair crews are dispatched from utility yards where excavation equipment and pipe materials are kept ready around the clock. These crews work through the night, cutting through asphalt, digging down to the broken pipe, isolating the damaged section with gate valves, and either clamping the brake or replacing the failed segment entirely. It is hard, physical labor performed under unpleasant conditions. The water pouring from a broken main is often frigid and muddy. The excavation site is lit by portable floodlights that attract insects in summer and cast harsh shadows in winter. Traffic has to be rerouted. Nearby residents have to be notified. And the repair has to be completed and pressure restored before the morning rush begins. Because hospitals, schools, restaurants, and fire hydrants all depend on that water being available. The people who do this work are not glamorous figures. They are pipe fitters, equipment operators, and utility workers who carry pagers and sleep with their phones on loud. They are part of a vast on-call workforce that most communities take entirely for granted. And the systems they maintain are, in many cases, genuinely old. Some American cities still have water mains made of wood. Others have cast iron pipes dating back to the late 1800s. The infrastructure was built to last, and in many cases, it has lasted far longer than anyone expected. But longevity is not the same as invincibility, and every night brings the possibility of another break, another repair, another quiet crisis managed before sunrise. Now, while utility crews are dealing with pipes and wires beneath the streets, something else entirely is happening on the surface. The roads themselves need maintenance, and most of that maintenance happens when traffic is lightest. Highway departments across the country schedule the majority of their road work for nighttime hours. Resurfacing projects, bridge inspections, lane markings, pothole repairs, sign installations, guardrail replacements, and overhead structure work all tend to happen between roughly 9 at night and 5 in the morning. The reason is straightforward. Closing a lane on a busy highway during rush hour creates traffic jams that can stretch for miles and last for hours. Closing the same lane at midnight causes minimal disruption. But nighttime roadwork introduces its own set of challenges. Visibility is reduced, which increases the risk of accidents in work zones. Workers operate under artificial lighting while vehicles pass at high speed just a few feet away. The Federal Highway Administration has reported that work zone crashes are a significant cause of injury and death for highway workers, and the risk is elevated at night despite lower traffic volumes because approaching drivers are more likely to be fatigued, distracted, or impaired. To mitigate these risks, nighttime work zones use elaborate traffic control setups. Lines of cones and barrels channel traffic away from the work area. Electronic message signs warn approaching drivers miles in advance. Arrow boards flash directional signals. And in some states, police cruisers with flashing lights are stationed at the upstream end of the work zone to slow traffic and create a buffer. The workers themselves wear high-visibility clothing with retroreflective strips designed to catch headlight beams. They communicate by radio because the noise of machinery and passing traffic makes normal conversation impossible. And they work with an awareness that their safety depends not just on their own vigilance, but on the behavior of every driver who passes through the zone at 70 miles per hour in the dark. It is a strange kind of labor. You do your best work when nobody is around to see it. And the only evidence of your effort is a smoother stretch of road that morning commuters will drive over without a second thought. This pattern, the idea that nighttime labor produces results that are consumed unknowingly during the day, repeats itself across nearly every sector of the American economy. And nowhere is it more apparent than in the food supply chain. Right now, while most kitchens in America are dark and empty, the systems that will feed those kitchens tomorrow are in full motion. And the chain begins much earlier than most people imagine. Consider a head of lettuce that you might buy at a grocery store in Philadelphia tomorrow afternoon. That lettuce was probably harvested in the Salinas Valley of California 2 or 3 days ago. It was cut from the field, packed into a carton, and loaded into a refrigerated trailer within hours of harvest. That trailer drove through the night across the desert Southwest, maintaining an interior temperature just above freezing to slow the biological processes that cause wilting and decay. The driver stopped for fuel in Arizona, checked the refrigeration unit in New Mexico, and crossed into Texas before dawn. Meanwhile, the distribution center where that lettuce is headed has been preparing for its arrival since the previous evening. Workers on the overnight shift have been unloading other trailers, sorting products by destination store, building mixed pallets of different items, and loading outbound trucks that will make early morning deliveries. The warehouse operates on a precise schedule because fresh produce has an extremely limited shelf life. A delay of even a few hours can mean the difference between a product that arrives crisp and saleable and one that arrives wilted and destined for the compost bin. The cold chain, as the industry calls it, is one of the most remarkable and fragile systems in the entire American economy. It is a continuous temperature-controlled pathway that stretches from the farm to the store shelf. And every link in that pathway has to hold. If the refrigeration unit on a trailer fails during a nighttime crossing of the Mojave Desert, the entire load can be lost. If a warehouse dock door is left open too long during a summer overnight shift, the temperature in the staging area can rise enough to compromise product quality. If an outbound delivery truck gets stuck in traffic and arrives at a store 2 hours late, the receiving crew may have already moved on to other tasks, and the product sits on a loading dock in the heat. These are not hypothetical problems. They happen every day. And the people who manage the cold chain overnight are engaged in a constant battle against time, temperature, and the second law of thermodynamics. They monitor trailer temperatures remotely using GPS-linked sensors. They adjust warehouse thermostat settings based on the volume and type of product being stored. They coordinate delivery schedules with store managers who need specific products at specific times to fill specific shelf positions before the store opens. It is logistical precision on a scale that most consumers never contemplate. And it all happens in the dark. But lettuce is just one product. The same overnight logistics apply to dairy, meat, seafood, baked goods, pharmaceuticals, flowers, and hundreds of other perishable items that Americans expect to find fresh every morning. The dairy truck that leaves a processing plant in Wisconsin at midnight will deliver milk to a distribution center in Illinois by 4 in the morning. The bread that you buy tomorrow was baked tonight at a commercial bakery that operates 3 shifts, with the overnight shift producing the loaves that will be on store shelves by 7 in the morning. Commercial bakeries are fascinating overnight operations. They run on schedules dictated by yeast, which does not care what time it is. Dough is mixed, proofed, shaped, proofed again, and baked in continuous cycles. The mixers are enormous, capable of handling hundreds of pounds of flour at a time. The proof boxes are temperature and humidity-controlled chambers where dough rises according to carefully calibrated timetables. The ovens are tunnel-style conveyor systems where loaves enter at one end, travel slowly through zones of increasing and then decreasing heat, and emerge fully baked at the other end. Workers monitor every stage, checking dough consistency, watching for proper rise, inspecting finished loaves for color, shape, and weight. The bread is then cooled, sliced, bagged, sealed, labeled with a sell-by date, and loaded onto delivery trucks. All before sunrise. The entire process, from raw flour to finished loaf on a store shelf, can happen in less than 12 hours. And it happens every single night at hundreds of bakeries across the country. This rhythm of overnight production feeding into morning consumption is the hidden heartbeat of the American food system. And it extends well beyond bakeries. At produce wholesale markets in cities like Los Angeles, Chicago, and New York, the busiest hours are between midnight and 5 in the morning. Buyers from restaurants, grocery stores, bodegas, and institutional kitchens arrive in the pre-dawn darkness to inspect pallets of fruits and vegetables, negotiate prices, and arrange delivery. The Hunts Point Terminal Produce Market in the Bronx, one of the largest in the world, handles billions of pounds of produce each year, and its peak activity happens when most of New York City is asleep. Walking through a market like Hunts Point in the middle of the night is a sensory experience unlike anything else. Forklifts shuttle between loading docks and warehouse bays. The air smells of ripe fruit and diesel exhaust. Voices echo off concrete walls in a dozen different languages. Buyers squeeze avocados and smell melons under fluorescent lights, while trucks idle outside, waiting to be loaded with the day's orders. It is loud, cold, and chaotic. And it is the reason that a restaurant in Manhattan can serve a fresh salad at lunch that was growing in a field in Mexico less than 48 hours earlier. This global supply chain that feeds into overnight domestic distribution is another layer of the nighttime economy that most people never see. Cargo ships arrive at American ports around the clock, and the unloading process does not wait for convenient hours. At the Port of Los Angeles, the largest container port in the Western Hemisphere, cranes operate through the night, pulling 40-foot steel containers off ships and stacking them in the terminal yard. Each container holds roughly 20 tons of goods, anything from electronics to furniture, to clothing, to auto parts. The cranes are operated by longshoremen sitting in cabs suspended 200 feet above the ground, using joysticks to position a spreader bar over a container with inches of clearance on each side. It requires extraordinary skill and concentration, and it happens in darkness, in wind, in rain, and on schedules that run 24 hours a day. Once a container is offloaded, it enters a sorting process that determines whether it will be loaded onto a truck for local delivery, placed on a rail car for cross-country transport, or held in the yard for customs inspection. This sorting is managed by terminal operating systems, sophisticated software platforms that track the location and status of every container in the port and optimize the sequence of moves to minimize handling time and maximize throughput. The port never truly sleeps. Even when ship arrivals slow, there are containers to be repositioned, chassis to be maintained, and documentation to be processed. Customs and Border Protection officers work overnight shifts to clear incoming cargo. Truck drivers line up at terminal gates before dawn, waiting for their appointed pickup times. And the whole operation feeds into the same highway and rail network that carries freight across the continent. While most Americans dream of anything but logistics, there is a term that supply chain professionals use that captures something essential about all of these overnight operations. They call it the invisible hand of logistics. It is a deliberate echo of Adam Smith's famous economic metaphor, but applied to the physical movement of goods rather than the theoretical movement of markets. The idea is that the supply chain functions so smoothly and so consistently that consumers experience its output as effortless abundance. The store has what you need. The package arrives on time. The fuel is in the pump. And you never have to think about why. But behind that effortlessness is an army of people working through the night. Forklift operators in warehouses, truck drivers on interstate highways, rail dispatchers in control centers, port crane operators on the waterfront, bakery workers in flour-dusted rooms, water treatment operators walking along aeration basins, electrical linemen climbing steel towers, gas technicians checking pressure regulators, road crews laying asphalt under floodlights. They do not know each other. They will never meet. They work in completely different industries, with completely different skills and training. But they are all part of the same system, the same unspoken agreement that America will work through the night so that America can function during the day. And the system they maintain is not just physical. It is also digital, because underneath and alongside all of the pipes, wires, rails, and highways, there is another network that never sleeps. The network of data. Right now, in windowless buildings scattered across the country, servers are humming. Data centers, the physical infrastructure of the internet and of virtually every modern business system, operate continuously with uptime targets that approach 100%. A major data center might guarantee 99.999% availability, which translates to less than 6 minutes of downtime per year. Achieving that level of reliability requires extraordinary engineering and round-the-clock human attention. The overnight shift at a large data center is a world unto itself. Technicians monitor thousands of servers, watching for hardware failures, temperature anomalies, and network irregularities. Cooling systems run constantly because the heat generated by thousands of processors can raise temperatures to dangerous levels within minutes if the cooling fails. Backup power systems, typically diesel generators and battery arrays, are tested regularly to ensure they can take over instantly if the utility power supply is interrupted. These data centers process the transactions, communications, and information flows that modern American life depends on. When you set your alarm clock on your phone before bed, the signal travels through a network that passes through one of these facilities. When a hospital records a patient's vital signs overnight, that data is stored in a system hosted in a data center. When a freight company tracks a truck's location by GPS, the position data flows through servers that are being maintained by someone working the night shift in a building that most local residents do not even know exists. It is infrastructure in the truest sense of the word. It sits beneath the surface of daily experience, essential but invisible. And like all infrastructure, it requires constant maintenance, monitoring, and the quiet dedication of people who understand that their job is to make sure nothing goes wrong. The theme that emerges from all of these overnight systems is not complexity, although they are certainly complex. It is interdependence. The food supply chain depends on the transportation network. The transportation network depends on the fuel supply. The fuel supply depends on the electrical grid. The electrical grid depends on the water system for cooling. The water system depends on the electrical grid for pumping. And all of them depend on the data networks for monitoring, communication, and control. This web of dependencies means that a failure in one system can cascade into failures in others with surprising speed. A power outage can shut down water pumps, which reduces pressure in fire suppression systems, which forces hospitals to implement emergency protocols, which diverts ambulances to other facilities, which increases response times across an entire region. The domino effect is not a metaphor. It is a real and constant risk that overnight operators are trained to recognize and interrupt. And yet the system works. Night after night, it works. Not because it is perfect, but because thousands of people are paying attention at the exact moments when most of the country is not. They are the night watch of a civilization that has built itself on the assumption of uninterrupted service. And they fulfill that assumption, quietly, reliably, in the dark. There is something worth pausing to appreciate in that. The morning you take for granted, the one where everything just works, is not an accident. It is the product of an overnight effort so vast and so well coordinated that it has become invisible. And maybe that invisibility is the highest compliment the system can receive. It means it is working exactly as intended. But the systems that run through the night are not limited to utilities, transportation, and food. There are other operations, less obvious but equally essential, that keep American life functioning while most people sleep. And some of them happen in places you would never think to look. One of the things that rarely crosses anyone's mind at 2 a.m. is an elevator. Not the kind in apartment buildings or small offices, but the ones in hospitals, skyscrapers, transit stations, and hotels. The ones that carry thousands of people every day and are expected to be ready the moment someone presses a button at 6 a.m. Those elevators need maintenance, and that maintenance happens at night. Elevator technicians are among the most specialized tradespeople in the country, and a significant portion of their work takes place during off hours when buildings are empty or operating at minimal capacity. They inspect cables, test safety brakes, calibrate door sensors, lubricate guide rails, and check the condition of the electrical systems that control car movement and floor leveling. In a high-rise building with dozens of elevators, this work can take an entire overnight shift just to cover a fraction of the equipment. The reason elevator maintenance is scheduled at night is not just about convenience. It is about safety and liability. Taking an elevator out of service during peak hours in a busy hospital or office tower creates immediate logistical problems. People cannot get to their floors. Emergency response is compromised. Building operations slow down. So the maintenance window is pushed to the hours when the fewest people are affected, which means technicians are riding on top of elevator cars at 3 a.m, headlamps on, checking sheave bearings and governor mechanisms in shafts that drop hundreds of feet into darkness below them. It is not work for the claustrophobic or the easily frightened. Elevator shafts are loud, greasy, and disorienting. The car moves while you are standing on top of it, and the walls of the shaft rush past at close range. Safety harnesses are mandatory, but the environment still demands a calm temperament and a thorough understanding of the mechanical systems involved. These technicians train for years before they are qualified to work independently, and the systems they maintain are governed by codes and inspection requirements that are among the most stringent of any building system. Most people step into an elevator without a moment of hesitation. That confidence exists because someone was in the shaft last night making sure it was earned. And elevators are just one example of the building systems that require overnight attention. In large commercial and institutional buildings, the heating, ventilation, and air conditioning systems run according to program schedules that shift between occupied and unoccupied modes. But the transition between those modes is not as simple as flipping a switch. Building engineers on the overnight shift monitor temperature readings across dozens or hundreds of zones, adjust damper positions, check refrigerant pressures, inspect air handling units, and respond to alarms triggered by sensors that detect abnormal conditions. A hospital, for instance, has air handling requirements that go far beyond comfort. Operating rooms must maintain positive pressure to prevent contaminants from entering. Isolation rooms must maintain negative pressure to prevent infectious particles from escaping. Pharmaceutical storage areas require precise temperature and humidity control. And the systems that maintain all of these conditions have to function continuously, which means someone is always watching them. At night, that someone is often a single building engineer responsible for an entire campus of interconnected systems, walking rounds through mechanical rooms and rooftops, checking equipment by flashlight, and responding to automated alerts on a handheld device. It is a job that combines deep technical knowledge with a tolerance for solitude. Overnight building engineers often work alone, moving through empty corridors and darkened hallways, their footsteps echoing in spaces that were crowded with people just a few hours earlier. They develop an intimate familiarity with their buildings that goes beyond what most occupants will ever experience. They know which valve makes a rattling sound when the steam pressure drops below a certain level. They know which air handler has a belt that needs replacing before it snaps. They know which rooftop unit tends to ice up on cold nights and needs to be checked before the defrost cycle kicks in. This knowledge is not written in any manual. It is accumulated through years of overnight observation, and it is what keeps the building comfortable and functional when everyone else arrives in the morning. Speaking of buildings, there is another overnight activity that most people encounter the results of every day without ever considering how it happens. Cleaning. The commercial cleaning industry in the United States employs millions of people, and the vast majority of their work is performed at night. Office buildings, schools, hospitals, airports, shopping malls, courthouses, and government facilities are cleaned after hours by crews that arrive in the evening and work through the early morning. They vacuum carpets, mop floors, sanitize restrooms, empty trash cans, wipe down surfaces, clean windows, and restock supplies. In a large office building, a cleaning crew might handle dozens of floors in a single shift, working methodically from top to bottom or bottom to top, depending on the building's protocol. This work is physically demanding, repetitive, and largely invisible. The people who do it are often among the lowest paid workers in the building. Yet the building could not function without them. A single day without cleaning in a busy office tower would produce overflowing trash bins, dirty restrooms, sticky floors, and an environment that most white-collar workers would find unacceptable. 2 days without cleaning, and the building would start to develop odor problems. A week, and you would begin to see pest issues. The cleanliness that people expect when they walk into a professional environment is maintained entirely by an overnight workforce that most of them never see and few ever think about. There is an interesting social dynamic at play here. The cleaning crew and the office workers occupy the same space but exist in almost entirely separate worlds. The office workers leave behind the evidence of their day, the coffee rings, the crumbs, the smudged glass, the overflowing recycling bins, and the cleaning crew erases that evidence before morning. It is a nightly reset, a quiet restoration of order that allows the daytime world to function as though it exists in a perpetual state of cleanliness. And the cleaning industry has its own supply chain, its own logistics, and its own overnight rhythm. Cleaning companies dispatch crews from central locations, loading vans with chemicals, equipment, and supplies before sending them out to multiple job sites across a metropolitan area. Supervisors make rounds to inspect quality and address problems. Supply companies deliver cases of paper towels, trash bags, and cleaning solutions to storage rooms in buildings that the day shift tenants never enter. It is an entire economy within an economy, operating almost entirely between the hours of 6 in the evening and 6 in the morning. Now, step outside those clean office buildings and consider the streets themselves. The streets that will carry morning rush hour traffic in a few hours are not simply sitting there passively in the dark. They are being maintained. Municipal street sweepers operate primarily at night in most American cities. These are specialized vehicles equipped with rotating brushes, vacuum systems, and water sprays that collect debris from curbs and road surfaces. The debris they pick up includes everything from leaves and litter to gravel and broken glass. In a city like Chicago or Houston, the street sweeping fleet covers thousands of lane miles over the course of a single night, following predetermined routes that ensure every major road is cleaned on a regular cycle. Street sweeping is not merely cosmetic. It serves an important environmental function. The debris that accumulates on road surfaces contains pollutants, heavy metals from brake dust, petroleum residues from vehicle emissions, fertilizer runoff from landscaped medians, and particulate matter from construction sites. If this material is not removed, it washes into storm drains during rain events and flows directly into rivers, lakes, and coastal waters. Street sweeping is classified as a best management practice for stormwater pollution prevention by the Environmental Protection Agency. It is, in effect, an environmental cleanup operation disguised as a housekeeping task. And it happens at night because operating large, slow-moving sweepers on busy daytime streets would create traffic hazards and reduce cleaning effectiveness. Alongside the sweepers, other municipal vehicles are working through the night as well. Garbage and recycling trucks begin their routes in the pre-dawn hours in many cities, particularly for commercial pickups. Restaurants, office buildings, and retail stores generate waste that must be collected frequently, and the collection often happens before business hours to avoid blocking sidewalks and parking areas with garbage trucks during the day. The sanitation workers who operate these trucks perform one of the most physically demanding and statistically dangerous jobs in the American economy. Collecting and compacting waste involves heavy lifting, exposure to sharp objects and hazardous materials, proximity to moving traffic, and operation of powerful hydraulic equipment. The Bureau of Labor Statistics has consistently ranked refuse and recyclable material collectors among the occupations with the highest rates of injury and fatality. And much of this risk is concentrated in the early morning hours when visibility is poor and the workers are performing repetitive tasks in the dark. And yet sanitation, like so many overnight services, is one of those functions that only becomes visible when it stops. A prolonged garbage collection strike, which has occurred periodically in various American cities throughout history, produces dramatic results within days. Trash piles up on sidewalks. Rats appear. Odors spread. Public health concerns escalate rapidly. The everyday miracle of waste disappearing from your curb is maintained by an overnight workforce that operates with remarkable efficiency and remarkably little public recognition. Now, there is another dimension of overnight America that we have not yet explored, and it operates at a scale that is difficult to fully grasp. Aviation. Most people associate airports with daytime travel. They think of terminals filled with passengers, departure boards showing destinations, and the familiar routine of check-in, security, and boarding. But the busiest airports in the country have a parallel overnight life that has almost nothing to do with passenger travel. Cargo aviation is a nighttime industry. The major cargo carriers, the ones that deliver packages, documents, and freight across the country and around the world, conduct the majority of their operations between roughly 10 at night and 6 in the morning. There is a very specific reason for this. The business model of overnight delivery depends on picking up packages during the business day, flying them to a central sorting hub at night, processing them through an automated sorting system, and then flying them back out to destination cities in time for morning delivery. The scale of this operation is staggering. At the main hub of one major cargo carrier in Memphis, Tennessee, over 300 aircraft arrive and depart on a typical night. Each plane carries tens of thousands of packages. Those packages are unloaded, scanned, sorted by destination, reloaded onto different aircraft, and sent back out, all within a window of roughly 4 to 5 hours. The sorting facility covers millions of square feet and employs thousands of workers on the overnight shift. Walking through one of these sort facilities during peak operations is like watching a mechanical organism breathe. Conveyor belts stretch in every direction, carrying packages at high speed through a labyrinth of scanners, diverters, and chutes. Barcode readers identify each package and route it to the correct destination lane. Human workers handle irregularly shaped items, oversized packages, and anything the automated system cannot process. The noise is constant, a low roar of belts, motors, and the occasional thud of a heavy package landing in a bin. Outside on the ramp, the aircraft are lined up in precise formations. Ground crews unload containers and loose packages from one set of planes, while loading outbound containers onto another set. Tugs pull cargo dollies across the tarmac. Fuel trucks top off aircraft tanks. Maintenance technicians perform quick inspections between flights. And the entire operation is coordinated by a ramp control tower that tracks every aircraft movement and every ground vehicle on the airfield. The precision required is extraordinary. A single aircraft arriving late can disrupt the entire sort schedule because the packages it carries are needed on outbound flights that depart on fixed timetables. A mechanical problem with a conveyor belt can create a bottleneck that backs up thousands of packages. A weather delay at a spoke station can force the hub to hold aircraft past their planned departure times, which compresses delivery windows and may result in late packages the next morning. The people who manage these overnight cargo operations are logistics professionals operating in an environment where every minute matters and the margin for error is measured in seconds. They have developed systems and protocols that rival the complexity of air traffic control, which is fitting because the aircraft they are managing are using the same airspace and the same runways as commercial passenger flights. And speaking of air traffic control, that system never sleeps either. Even at the quietest airports, control towers are staffed through the night, and the en route centers that manage aircraft flying at high altitude operate continuously. A cargo flight crossing the country at 2 in the morning is being tracked by the same radar systems and managed by the same controller workforce that handles passenger jets during the day. The controllers work rotating shifts that include overnight assignments, and the challenges of maintaining alertness and performance during these shifts are a constant concern in the aviation safety community. The Federal Aviation Administration has studied the effects of fatigue on controller performance extensively, and the scheduling rules that govern controller shifts reflect a delicate balance between operational needs and human limitations. Controllers are required to have minimum rest periods between shifts and maximum duty times during shifts. But the nature of overnight work, sitting in a darkened room, watching a radar screen and communicating with occasional aircraft during long quiet periods, creates fatigue risks that are different from those faced during busy daytime shifts. The challenge is not too much work, but too little stimulation, which can lead to a dangerous drop in vigilance. This same challenge affects many overnight workers across every industry we have discussed. The human body is not designed for nocturnal wakefulness. Our circadian rhythms, the internal biological clocks that regulate sleep and alertness, are calibrated to a cycle of daylight and darkness that evolved over millions of years. Working against that cycle exacts a physiological toll that researchers have documented extensively. Overnight workers have higher rates of cardiovascular disease, metabolic disorders, and mental health issues compared to their daytime counterparts. They are more prone to errors and accidents during the circadian low point, which typically occurs between 2 and 5 in the morning. And yet, millions of Americans do this work every night. They have found ways to adapt, using strategic napping, controlled caffeine intake, careful light exposure, and adjusted sleep schedules. Some adapt better than others. Some never fully adjust. But they continue to show up for the night shift because the systems they maintain cannot wait until morning. There is something quietly heroic about that. Not heroic in the dramatic sense, not the kind of heroism that makes headlines, but heroic in the steady, unglamorous sense of people doing essential work at personal cost because it needs to be done. The water treatment operator who checks dissolved oxygen levels at 4 in the morning is not going to receive a medal for it. The elevator technician working alone in a shaft at midnight is not going to be featured in a news story. The cargo sort worker scanning packages at 2 in the morning is not going to be thanked by the person who receives the delivery the next day. But they all contribute to the same outcome, a morning that works, a day that starts smoothly, a civilization that continues to function without interruption. This is the hidden contract that underlies American life. A vast workforce agrees to operate in the dark, maintaining systems and moving goods and monitoring networks, so that the rest of the population can enjoy the illusion that everything simply works on its own. It is not a formal agreement. It is not written down anywhere. But it is as real and as binding as any law or regulation. And it is renewed every night when the sun goes down and the invisible workforce goes to work. By now, the night is wearing on. The earliest hints of gray are beginning to appear on the eastern horizon. And across the country, the systems that have been operating in darkness are beginning to shift gears. The overnight maintenance windows are closing. The last freight trains are pulling into their destination yards. The bakery trucks are making their final deliveries. The cargo planes are landing at spoke stations with their sorted packages. The street sweepers are returning to their depots. The cleaning crews are packing up their equipment and heading home. And a new set of workers is waking up, eating breakfast, and preparing to take over. The day shift does not know exactly what happened during the night. They do not need to. All they need to know is that the systems are intact, the supplies are in place, and the infrastructure is ready for another day of service. But before the dawn fully breaks, there is one more hidden system worth understanding. One that ties together everything we have discussed and reveals just how fragile and how resilient the overnight infrastructure really is. And it starts with a question that engineers have been asking since the earliest days of industrialization. What happens when everything goes wrong at once? The question of what happens when everything fails simultaneously is not academic. It has been answered repeatedly by events that most Americans remember only as headlines, but that engineers and infrastructure planners study as case histories for years afterward. In late October of 2012, a storm named Sandy made a landfall on the New Jersey coast with a combination of wind, rain, and storm surge that overwhelmed virtually every overnight system we have discussed. The surge pushed seawater into subway tunnels in lower Manhattan, flooding stations that had operated continuously for over a century. Electrical substations shorted out, plunging entire boroughs into darkness. Wastewater treatment plants lost power and began discharging raw sewage into waterways. Fuel distribution terminals were inundated, cutting off gasoline supplies to an entire region. And the transportation network, the trucks and trains and ships that keep the supply chain moving, ground to a halt. What happened in the days that followed was, in many ways, more revealing than the storm itself. Because it showed what happens when the invisible systems become visible. People who had never thought about where their electricity came from suddenly cared deeply about the condition of underground transmission cables. People who had always taken clean water for granted found themselves boiling tap water or standing in line for bottled supplies. People who assumed gasoline would always be available at the corner station waited for hours in lines that stretched for blocks, rationing their remaining fuel for essential trips only. The systems that had operated silently in the background for years were suddenly the only thing anyone could talk about. And the workers who maintained those systems, the people who had always been invisible, became essential in a way that was impossible to ignore. Utility crews from across the country converged on the affected area through a mutual aid system that is one of the most remarkable and least known features of American infrastructure. Under this system, Utilities in unaffected regions send crews, equipment, and supplies to help restore service in disaster zones. After Sandy, line crews from as far away as California and Florida drove their bucket trucks across the country to help rebuild the electrical grid in New York and New Jersey. They worked 18-hour days in freezing rain, sleeping in their trucks or in makeshift camps set up in parking lots. They reconnected neighborhoods one street at a time, working through the night because the need was too urgent to stop for darkness. The mutual aid system works because utilities have pre-established agreements and standardized equipment that allows crews from one company to work on another company's infrastructure. A lineman from Georgia can splice a cable in Connecticut because the tools, the techniques, and the safety standards are essentially the same. It is a form of nationwide cooperation that operates outside of the political system, driven entirely by professional solidarity and the shared understanding that infrastructure failure anywhere is a threat to infrastructure everywhere. Sandy also exposed the vulnerability of fuel supply chains in ways that changed how the industry operates. The petroleum terminals along the New York Harbor that supply gasoline to the entire Northeast were built at sea level, which made them efficient for receiving tanker shipments, but catastrophically vulnerable to storm surge. When those terminals flooded, the pumps that moved fuel from storage tanks to delivery trucks were destroyed. Even after the roads were cleared and the gas stations had power, there was no fuel to deliver. The shortage lasted for weeks and created a secondary crisis on top of the primary one. In response, the federal government and the petroleum industry developed new protocols for pre-positioning fuel supplies, hardening terminal infrastructure, and establishing emergency distribution networks that can be activated before a storm makes landfall. These protocols are now part of the overnight planning that happens in energy sector control rooms whenever a major weather event is forecast. Dispatchers begin moving fuel inventories inland, arranging for emergency generator fuel deliveries to critical facilities, and coordinating with pipeline operators to increase flow rates into potentially affected areas. It is a form of preventive logistics, moving supplies before they are needed, based on forecasts that may or may not prove accurate. This kind of anticipatory planning has become a defining feature of overnight infrastructure management across the country. It is not enough to respond to problems as they occur. Modern infrastructure operators are expected to see problems coming and act before they arrive. Weather forecasting plays a central role in this. The National Weather Service issues forecasts and warnings around the clock, and the overnight shift at NWS forecast offices is particularly important because many severe weather events, including tornadoes, flash floods, and winter storms, develop or intensify during the nighttime hours. Forecasters working the overnight shift monitor radar imagery, satellite data, surface observations, and computer model outputs to track developing weather systems and issue warnings to the public. The warnings they issue trigger a cascade of overnight preparations across multiple sectors. Highway departments pre-position salt trucks and snowplows along routes where winter storms are expected. Utility companies activate storm response plans and place repair crews on standby. Emergency management agencies open coordination centers and begin notifying hospitals, shelters, and first responders. Water utilities increase reservoir levels to ensure adequate supply in case of pump failures. And all of this happens while most of the public is asleep and unaware that preparations are underway. The effectiveness of these overnight preparations can mean the difference between a manageable disruption and a catastrophic failure. When a winter storm strikes a city that has pre-treated its roads and positioned its plows, the morning commute may be slow but functional. When the same storm strikes a city that was caught off guard, the result can be gridlocked highways, stranded motorists, and a cascade of secondary emergencies that overwhelm the response system. This brings us to a concept that engineers and infrastructure planners think about constantly, but rarely discuss publicly. Resilience. Resilience is not the same as prevention. Prevention means stopping bad things from happening. Resilience means maintaining function when bad things do happen. And the overnight infrastructure of America is built on resilience far more than it is built on prevention. Because the truth is, you cannot prevent everything. Equipment will fail. Weather will be extreme. Demand will spike unexpectedly. Human errors will occur. The question is whether the system can absorb those shocks and continue operating, or whether it collapses under the strain. The answer, most of the time, is that it absorbs them. And the reason it absorbs them is because of the layered redundancy that has been built into virtually every critical system. The electrical grid has backup generators at hospitals and water treatment plants. The water system has elevated storage tanks that can supply pressure even if pumps fail. The natural gas network has multiple supply sources and interconnections that allow gas to be rerouted around damaged sections. The transportation network has alternate routes that can absorb traffic when primary corridors are blocked. The food supply chain has regional distribution centers that can substitute for each other if one is knocked offline. None of these backup systems are perfect. They all have limitations and capacity constraints. But they exist because generations of engineers have studied past failures and asked the same question each time. How do we make sure this does not happen again? And the answer is almost always the same. Build in redundancy. Create alternatives. Assume the worst and plan for it. This philosophy of redundant design is so deeply embedded in American infrastructure that most people do not realize it is there. They experience its effects without understanding its cause. When a water main breaks and pressure drops, but water still comes out of the tap, that is redundancy at work. When a power line goes down in a storm, but the lights flicker and come back on within seconds, that is an automatic switching system transferring load to an alternate circuit. When a highway is closed for construction and traffic is detoured but still moves, that is network redundancy providing alternate paths. The overnight hours are when much of this redundancy is tested, maintained, and restored. Backup generators are run weekly or monthly to ensure they start and operate properly. Alternate water supply connections are exercised to verify they can deliver adequate flow. Spare transformers are inspected and inventoried. Emergency communication systems are tested. And all of this maintenance and testing happens at night because it requires taking primary systems temporarily offline, which is safest to do when demand is lowest. There is a certain elegance to this system of systems, not the elegance of simplicity, because there is nothing simple about it, but the elegance of something that works despite its complexity. Like a coral reef or a rainforest, the overnight infrastructure of America is an ecosystem where thousands of independent components interact in ways that produce an outcome far greater than any individual part could achieve alone. No single power plant keeps the lights on. No single water main supplies a city. No single truck feeds a population. But together, coordinated by a web of communications, protocols, and human judgment, they produce a result that we experience as normalcy. And normalcy, it turns out, is the most extraordinary product of all, because normalcy requires that nothing goes noticeably wrong. It requires that the electricity is there, the water is clean, the roads are passable, the food is fresh, the fuel is available, the buildings are comfortable, the data is flowing, the packages are delivered, and the waste is collected every single night, without exception, and the margin of tolerance for failure is remarkably narrow. One bad night, one system breakdown that is not caught and corrected in time, and the morning that follows is a morning of crisis rather than routine. The people who work overnight understand this in a way that daytime workers generally do not. They carry the weight of knowing that the normal morning their neighbors expect depends on their vigilance during the hours when no one is watching. It is a responsibility that does not come with much recognition, but that shapes how they approach their work. A water treatment operator does not skip a test because it is 4 in the morning and the results have been normal for weeks. An electrical dispatcher does not ignore a minor frequency deviation because it will probably correct itself. A truck driver does not skip a pre-trip inspection because the rig was fine yesterday. The culture of overnight work is a culture of thoroughness because the consequences of cutting corners are too serious to risk. This culture is transmitted not through formal training alone, but through mentorship, experience, and the accumulated wisdom of people who have been doing the work for decades. A new overnight operator at a water treatment plant learns from watching a veteran operator respond to an unusual turbidity reading. A new lineman learns from watching an experienced colleague diagnose a transformer, fault by sound alone. A new truck driver learns from riding with a veteran who knows every way station, every steep grade, and every truck stop with decent coffee between Pennsylvania and Ohio. This transfer of knowledge is one of the most underappreciated aspects of overnight infrastructure. The systems themselves are engineered, but the operation of those systems depends on human judgment that cannot be fully captured in manuals or procedures. Knowing when a pump sounds different than usual, knowing which circuit breaker tends to trip in humid weather, knowing which stretch of highway is prone to black ice on clear, cold nights. This is the knowledge that keeps the systems running. And it is held by the people who work the night shift, passed from one generation of workers to the next in the quiet hours when there is time to talk and teach. But this knowledge is also vulnerable. The workforce that maintains America's overnight infrastructure is aging. Many of the most experienced operators, technicians, and engineers are approaching retirement. And recruiting younger workers into overnight roles is a persistent challenge across multiple industries. The hours are difficult. The work is often physically demanding. The lifestyle sacrifices are real. And the compensation, while generally decent, does not always reflect the level of skill and responsibility involved. This is one of the quiet concerns that keeps infrastructure managers awake at night. Ironically enough, the systems they oversee are only as good as the people who operate them. And if the pipeline of skilled overnight workers dries up, the systems will begin to degrade. Not dramatically at first, not in ways that make the news, but gradually, incrementally, as institutional knowledge is lost and maintenance is deferred, and response times lengthen, and minor problems that would have been caught early are allowed to grow into major ones. It has happened before, In cities where budget cuts have reduced overnight staffing at water treatment plants, the quality of treated water has declined. In regions where experienced grid operators have retired without adequate replacements, the risk of cascading outages has increased. In industries where overnight maintenance crews have been downsized, equipment failure rates have risen. The correlation between workforce quality and system reliability is not theory, it is documented history. And so the question of how America keeps running while you sleep is not just a question about machines and pipes and wires and trucks. It is a question about people, about the willingness of human beings to work through the night, year after year, maintaining systems that most of their fellow citizens take for granted, about the skills and knowledge that make that maintenance possible, about the culture of diligence and responsibility that sustains it, and about the societal commitment to investing in these people and their work, even when that work is invisible. Because the machine only runs as long as someone is willing to tend it. Right now, as you listen to this, the night is moving toward morning somewhere in America. In the Eastern time zone, the sky may already be lightening. In the Mountain West, the stars are still out. In Alaska, depending on the season, it may be fully dark for many more hours. But wherever the night persists, the systems are running. Pumps are pushing water through underground mains. Generators are spinning in power plants. Gas is flowing through pipelines. Trains are rolling across plains and through mountain passes. Trucks are pulling into distribution centers. Cargo planes are landing at sorting hubs. Cleaning crews are finishing their last buildings. Bakers are pulling the first loaves from the ovens. Street sweepers are making their final passes. Control room operators are watching screens and making adjustments. And somewhere, an overnight worker is stepping outside for a moment of fresh air. Maybe at a water treatment plant on the edge of a river. Maybe on the platform of a rail yard. Maybe on the loading dock of a warehouse. They stand there in the quiet, feeling the cool air, and look up at the sky. They know the sun will be up soon. They know their shift is almost over. And they know that when the rest of the country wakes up and starts another day, very few people will have any idea what it took to make that day possible. But they know, and that is enough. The morning comes, the coffee brews, the lights turn on, the water flows, the shelves are stocked, the roads are clear, the elevators work, the buildings are clean, the packages have arrived, the fuel is in the pump, the hospitals are running, the data is flowing. Everything works, just like it did yesterday, just like it will tomorrow. And tonight, when you close your eyes and drift off to sleep, it will all begin again. The invisible workforce will clock in. The systems will hum to life. The trucks will roll. The trains will move. The pumps will run. The operators will watch their screens. The technicians will inspect their equipment. The bakers will mix their dough. The sweepers will clean the streets. America will keep running. It always does. Not because the systems are perfect, not because failure is impossible, but because every night, in every corner of this country, someone shows up to do the work that makes the morning possible. And that, when you think about it, is one of the most remarkable things about this place. Not its size, not its wealth, not its technology, but the simple, stubborn, unglamorous commitment to keeping things running. One night at a time, one shift at a time, one quiet act of maintenance at a time. The world you wake up to is not an accident. It is a gift, delivered in the dark by people you will never meet, working through hours you will never see, maintaining systems you will never think about. Until now. Sleep well. They have got it from here. There is one more world worth visiting before the night is over. One that operates so far from public view that even many infrastructure professionals rarely encounter it. It is the world beneath the world. The tunnels. Beneath every major American city, there exists a network of tunnels that most residents will never see and few even know about. Not the subway tunnels, although those are part of it. Not the sewer mains, although those run alongside them. But utility tunnels, steam tunnels, communications conduits, and maintenance passageways that form a hidden skeleton beneath the streets. And these tunnels require constant overnight attention. In New York City, there is a steam system that has been operating since 1882. It is the largest commercial steam system in the world, delivering steam through over 100 miles of pipes beneath the streets of Manhattan to heat and cool more than 1,700 buildings. The steam is produced at generating stations and distributed through a network of mains that run under avenues and cross streets, some of them more than a century old. And the maintenance of this system happens almost entirely at night. Crews descend through manholes into vaults where steam pipes run at pressures that can exceed 150 pounds per square inch and temperatures that can reach 390 degrees Fahrenheit. They inspect pipe joints, replace insulation, test pressure relief valves, and look for signs of corrosion or stress that could lead to a rupture. A steam pipe failure in a densely populated urban area is not merely an inconvenience. It is a genuine danger. In 2007, an 83-year-old steam main ruptured beneath Lexington Avenue in Midtown Manhattan, sending a geyser of steam and debris several stories into the air during rush hour. One person died and dozens were injured. The investigation that followed revealed that the pipe had been weakened by years of groundwater infiltration and the constant vibration of traffic above. That incident reinforced what steam system engineers had long known. The only way to prevent catastrophic failures is relentless inspection, and the only practical time to conduct those inspections is at night when steam demand is lower and street activity is minimal. The crews who do this work operate in conditions that most people would find intolerable. The tunnels are hot, humid, cramped, and then noisy. Visibility is often limited to the range of a headlamp. And the consequences of a mistake, a valve opened too quickly, a pressure reading misinterpreted, a weakened pipe section overlooked, can be severe. But steam is only one of the utilities that occupy the underground. In many cities, the same tunnel corridors carry electrical cables, fiber optic lines, telephone conduits, water mains, gas pipes, and sometimes pneumatic tube systems left over from an earlier era. The density of underground infrastructure in a city like Boston or Chicago or San Francisco is almost impossible to visualize without seeing it firsthand. Layers of pipes and cables installed over more than a century occupy nearly every available inch of space beneath the roadway. And when one of these utilities needs repair or replacement, the work often requires navigating around or through the others. A three-dimensional puzzle that utility crews solve in the dark, underground, night after night. There is a phrase that underground utility workers use that captures the reality of their environment. They call it the spaghetti, because when you open a street and look down, that is exactly what it looks like. A tangled mass of pipes, conduits, and cables of different ages, materials, and sizes, some mapped and documented, some not. The oldest utilities were often installed without precise records of their location. Over the decades, as new utilities were added, the underground became increasingly crowded and increasingly difficult to work in. Today, before any excavation can begin, utility locating services must be called in to identify and mark the approximate position of every buried line. Even with modern ground-penetrating radar and electromagnetic locating equipment, surprises are common. A backhoe operator digging for a water main repair at 2 in the morning may encounter an unmarked gas line, an abandoned conduit filled with asbestos insulation, or a live electrical cable that was supposed to be 3 feet to the left according to the records. These surprises are why underground utility work is one of the most hazardous occupations in the construction and maintenance industries. Workers face risks from cave-ins, electrocution, gas exposure, flooding, and the simple physical danger of working in confined spaces with heavy equipment. And the overnight hours add an additional layer of risk because fatigue, reduced visibility, and limited access to support resources all increase the probability of accidents. Despite these challenges, the underground work continues every night because it must. The infrastructure beneath American cities is aging, and the pace of deterioration is accelerating. The American Society of Civil Engineers has given the nation's infrastructure a grade that has hovered near the bottom of the scale for decades, and much of the worst deterioration is underground where it cannot be seen. Water mains that were installed before the First World War still in service. Sewer pipes made of clay and brick are still carrying wastewater beneath streets that have been paved and repaved dozens of times. Gas mains made of cast iron, a material that becomes brittle with age and is prone to cracking, are still distributing natural gas beneath neighborhoods where children play and families sleep. Replacing this aging infrastructure is an enormous undertaking that will take decades and cost hundreds of billions of dollars. And much of the replacement work happens at night, 1 block at a time, 1 pipe at a time, in a slow and methodical process that rarely makes the news, but gradually, almost imperceptibly, renews the hidden foundation that everything else depends on. Above ground, there is another overnight operation that most people encounter every day, without realizing it has a nighttime component. Traffic signals. The traffic signals that regulate movement at intersections across the country are not standalone devices. They are networked systems managed by traffic management centers that operate around the clock. During the day, these centers monitor traffic flow using cameras, loop detectors embedded in the pavement, and increasingly, data feeds from connected vehicles and smartphone applications. They adjust signal timing in real time to respond to congestion, accidents, and special events. At night, the role of the traffic management center shifts. With traffic volumes much lower, many signals switch from their normal cycle patterns to flashing mode, red in one direction and yellow in the other, to allow free flow on the primary corridor while requiring cross-street traffic to stop. but not all signals can be switched to flash mode. Intersections near hospitals, fire stations, and other critical facilities often remain in full cycling mode around the clock. And the determination of which signals flash and which continue cycling is itself a carefully considered engineering decision based on crash history, sight distances, pedestrian activity, and the presence of nearby land uses that generate nighttime traffic. Traffic signal maintenance is another overnight activity. Technicians replace burned-out bulbs, although LED signals have dramatically reduced the frequency of this task. They repair damaged signal heads, replace controllers that have malfunctioned, adjust detection systems, and update timing plans. Much of this work requires briefly shutting down a signal, which is safest to do when traffic is lightest. A signal technician working at an intersection at 3 in the morning is typically accompanied by a crew that sets up temporary traffic control, including signs and flaggers, even though traffic may be almost non-existent. The safety protocols are followed regardless of volume because the consequences of a collision at a dark intersection with a disabled signal are too serious to risk. And traffic signals are just one element of the broader intelligent transportation system that monitors and manages the movement of vehicles across the American road network. Highway management centers in major metropolitan areas operate around the clock, watching freeway cameras, monitoring speeds using detector stations, and coordinating with law enforcement and emergency services when incidents occur. At night, these centers are often staffed by a skeleton crew that must cover the same geographic area with fewer resources. A single operator may be responsible for monitoring hundreds of miles of highway, watching for disabled vehicles, debris in the roadway, wrong-way drivers, and other hazards that become more likely in the overnight hours when driver impairment and fatigue are more prevalent. When an overnight operator detects an incident, the response must be swift. A disabled vehicle in a travel lane on a dark highway is an extreme hazard. An operator who spots it on camera will immediately dispatch service patrol trucks, which are roving vehicles that patrol the highway system at night specifically to assist with incidents. These trucks carry basic supplies like fuel, water, and fix-a-flat, as well as traffic control equipment like cones and flares. Their primary mission is to get disabled vehicles off the roadway as quickly as possible, either by providing minor assistance or by arranging for a tow. Every minute a vehicle sits in a travel lane in the dark is a minute during which a high-speed rear-end collision becomes more likely. The service patrol concept was pioneered by a handful of states in the 1990s and has since spread to most major metropolitan areas. The drivers who operate these trucks work the overnight shift by choice in most cases, and they develop an intimate knowledge of their assigned highway segments. They know the locations where breakdowns are most common, usually long uphill grades where older vehicles overheat and curves where tire failures tend to cause loss of control. They know the times of night when impaired driving incidents peak, typically between midnight and 3 in the morning on weekends. And they know the feeling of being the only help available on a dark stretch of highway, where the nearest police unit may be 20 minutes away. Now let us turn to something that ties together many of the systems we have been discussing, but is rarely thought of as infrastructure in its own right. Communication networks. Every overnight operation we have described depends on communication. Grid operators talk to power plant controllers. Water treatment operators send data to regulatory systems. Train dispatchers communicate with locomotive engineers. Truck drivers receive routing instructions from logistics centers. Cargo sort facilities coordinate with aircraft operations. Traffic management centers communicate with emergency services. And all of these communications flow through networks that must be maintained and monitored continuously. The telecommunications infrastructure of the United States is a vast and complex system of fiber optic cables, copper lines, microwave towers, cell sites, switching centers, and satellite links that carries voice, data, and video traffic across the country and around the world. And like every other system we have discussed, it requires overnight maintenance and monitoring. At telephone company central offices and data switching centers, technicians work overnight shifts monitoring equipment performance, replacing failed circuit cards, splicing fiber optic cables, and testing connections. The telephone network, despite being thought of as old technology, remains critical infrastructure because it carries not only voice calls, but also data circuits that support internet service, alarm systems, credit card processing, and emergency communications. A failure at a central office can take out telephone and internet service for thousands of customers, which in turn can disable burglar alarms, medical alert systems, and the ability to call for emergency help. Fiber optic cables, which carry the majority of long-distance voice and data traffic, are vulnerable to physical damage from construction, vehicle accidents, and natural events. When a fiber cable is cut, the effect can be widespread and immediate. Thousands of telephone calls may be dropped. Internet service may be disrupted across a large area. Businesses that depend on data circuits for credit card processing or inventory management may be unable to operate. And because fiber cables often carry circuits for multiple service providers, a single cable cut can affect customers of several different companies simultaneously. Fiber repair is specialized and time-sensitive work. Technicians must locate the exact point of damage, which may be buried underground or strung on aerial poles. They must set up a splice enclosure, strip the damaged fiber strands, clean them, align them using a precision fusion splicer that joins the glass fibers with a microscopic electric arc, and test the repaired splice for signal loss. A single cable may contain hundreds of individual fiber strands, and each one must be spliced individually. The process can take hours, and it often happens in the middle of the night, in a muddy ditch beside a highway, or on a utility pole in freezing rain. The technicians who perform this work carry equipment worth tens of thousands of dollars and possess skills that take years to develop. They are not the people you think of when you think about your internet connection, but they are the reason your internet connection exists. And when it goes down at 2 in the morning and comes back up by breakfast, it is because one of these technicians drove out to a damaged cable in the dark and spent hours restoring it while you slept. Wireless networks require overnight attention as well. Cell towers are complex installations with radio equipment, power systems, backup batteries, and connections to the fiber network. They require regular maintenance, software updates, and hardware replacements. And much of this work is done at night to minimize disruption to subscribers. Tower climbers, who are among the most specialized and physically courageous workers in the telecommunications industry, sometimes perform their work at night when wind conditions are calmer and thermal effects on the tower structure are more stable. Climbing a cell tower at night is not for everyone. The towers can be several hundred feet tall, and the climber ascends using a combination of fixed ladders, step pegs, and safety climb systems that attach to a vertical rail. At the top, the climber may need to replace an antenna, swap out a radio unit, or connect a new cable, all while secured to the structure by a harness and working by headlamp. The view from the top of a cell tower at night, with the lights of a city spread out below and the stars overhead, is said to be extraordinary. But most tower climbers are too focused on their work to enjoy the scenery. The communication networks they maintain are the nervous system of overnight America. Without them, the grid operators could not coordinate power flows. The water treatment plants could not report their data. The train dispatchers could not issue movement authorities. The truck drivers could not receive routing updates. The cargo facilities could not track packages. The hospitals could not transmit patient records. The emergency services could not receive calls. Every system we have discussed depends on the communication network, and the communication network depends on the overnight technicians who keep it running. This interdependence brings us back to where we started. The recognition that overnight America is not a collection of separate systems operating independently. It is a single, interconnected organism where every part affects every other part. Electricity enables water treatment, which enables fire suppression, which enables building occupancy, which enables the economy, which generates the revenue that funds the electrical utility. Transportation moves the fuel that powers the generators, that produce the electricity that runs the pumps that fill the water towers, that provide the pressure that serves the hospitals that care for the workers who maintain the transportation system. It is circular. It is recursive. And it operates with a degree of coordination that no single authority controls or even fully understands. The closest analogy might be a living body. Your heart pumps blood without consulting your lungs. But if your lungs stop working, your heart will eventually fail too. Your nervous system coordinates movement without negotiating with your digestive system. But if your digestive system shuts down, your nervous system will run out of energy. The body works because all of its systems operate continuously and automatically without requiring conscious attention. And when something goes wrong, the body has mechanisms to detect the problem and respond before it becomes catastrophic. Fever, pain, inflammation. These are not failures. They are responses to failure, signals that something needs attention. Overnight infrastructure works the same way. The alarm that sounds in a control room is not a failure. It is a signal that a failure is beginning and that human attention is needed. The pressure drop in a water main is not a catastrophe. It is an early warning that a break has occurred and that repair crews should be dispatched. The frequency deviation on the electrical grid is not a blackout. It is an indication that supply and demand are out of balance and that corrective action is required. The overnight workers who respond to these signals are the immune system of the infrastructure. They detect problems, diagnose causes, and implement solutions before the problems become crises. And like the immune system of a living body, they work most effectively when you do not even know they are there. It is worth sitting with that thought for a moment. The most successful infrastructure is the infrastructure you never notice. The best overnight workers are the ones whose efforts leave no trace by morning. The highest achievement in this world is invisibility, the complete absence of evidence that anything was ever wrong. And that invisibility is not a natural condition. It is manufactured. It is maintained. It is the product of deliberate effort by people who have chosen to work in the dark so that the rest of us can live in the light. There is a philosophical dimension to this that goes beyond engineering. It touches on something fundamental about how civilizations sustain themselves. Every society that has ever existed has depended on a class of workers who perform essential labor that the broader population does not see or acknowledge. The aqueduct builders of Rome, the night soil collectors of medieval cities, the lamplighters of Victorian London, the signal operators of early railroad networks. These were the invisible workers of their eras, and they were as essential to the functioning of their societies as any general or merchant or politician. Modern America is no different. The invisible workers of tonight are the linemen and pump operators and truck drivers and sort facility workers and cleaning crews and tunnel maintenance teams and fiber splicers and tower climbers who keep the systems running. They are not invisible because they are unimportant. They are invisible because they are so good at what they do that the rest of us never have to think about it. And perhaps that is the final, quiet lesson of the American night. The things we take most for granted are the things that require the most effort to maintain. The morning that feels effortless is the product of a night full of labor. The normalcy that seems automatic is the result of constant vigilance. And the civilization that appears to run itself is actually run by millions of hands, working in the dark, one shift at a time. The sun is coming up now. Somewhere in America, a night shift worker is driving home. The roads are still quiet. The radio is playing softly. The coffee in the cup holder has gone cold. They are tired. Their hands may be dirty. Their back may ache. But they know that somewhere behind them, the system they spent the night maintaining is ready for another day. They will sleep through the morning while the rest of the country uses what they built. And tonight, they will do it all again. This is how America keeps running while you sleep. Not with grand gestures or dramatic interventions, but with quiet competence, steady hands, and the willingness to show up when no one is watching. Every single night, without fail. And now you know.